So I thought we'd just do a quick overview of the key components of the XIP. XIP-49 is, I believe, the longest XIP we've ever produced, and it's a lot to dig through. But there's a few areas that are particularly relevant for builders in the community to be aware of well before this gets shipped into production. So you can start thinking about how this might change your apps. Before we dig into the specifics of the proposal, it's helpful to think through what are the goals we had when designing a decentralized backend for XMTP. We knew we wanted there to be censorship resistance, so we can have many nodes that are all coordinating the replication of messages. But it also needs to be high throughput and low latency. This is a messaging network that we want to take on apps like Telegram and WhatsApp. And when you use an app like that, you expect a message to get delivered really quickly. And if it took blockchain times to deliver most messages in WhatsApp, you would just go to another app. We need things to get delivered in hundreds of milliseconds, not seconds, end to end, including, onto people's phones in different places in the world. And so those are really tight requirements for the latency of the system. And then the last item here is it needs to be cheap. These aren't multi-million-dollar DeFi transactions where maybe it's okay to pay a few dollars to get a message onto the network, like you might mainnet Ethereum. We need a network that is cheap enough that an app can subsidize it on behalf of many users and not break the bank. And so that forces us to be really disciplined in the design of the system to facilitate really cheap storage, much cheaper than a typical blockchain network. And I think we have a design that lets us check these boxes. So the way we accomplish this is a two-pronged architecture. Most messages in a post-XIP-49 world stay off-chain in a network of nodes. The reason we keep them off-chain is for both speed and cost, but this network of nodes has some strict rules around how it signs messages that it receives and how it replicates those messages to all the other nodes in the network. But then it can do this without a lot of fancy data structures, and that makes it much cheaper to store millions and millions of messages on these off-chain nodes. And that network works pretty well for storing messages that don't have ordering requirements. So maybe you get message 2 and then you get message 1 and message 3 comes a little later. That's perfectly fine for normal messages that happen in a conversation. But there's a few types of messages on the XMTP network that have stricter requirements. When you are updating your identity, we need total ordering to determine if an update is valid or not. And when you're changing the state of a group chat, say adding a member or removing a member, those need to be totally ordered. And so what we have done is split out the small subset of messages that need total ordering and put them on a set of technology that's quite good at total ordering, which is a blockchain. And so there is an L3 app chain that settles to base that handles this subset of messages that needs total ordering, and then the very cheap and fast network for everything else. And by doing that, we get the total ordering guarantees we need, but we also can minimize the average cost of sending a message. The messages on the blockchain will be more expensive because blockchains, but there should be relatively few of them. And so your average cost will be closer to the off-chain network. Messages in this architecture can be published to one node, or you can publish to multiple nodes to really protect yourself against any potential censorship in the network. That's not the only layer of censorship resistance, but it's one more layer that you can choose an application developer to add on top, which is just publishing your message more than once. So I've been talking a lot about cheapness and costs. Maybe this is a good segue to the payer service. This is a new part of an apps architecture in XMTP, specifically for apps that are serving many users. Not every app will need a payer service. Maybe you have a bot and there's only one application and one identity on our network, in that case, you might not need a payer service. But if you're an inbox app that has thousands or millions of users, you don't necessarily want them to have to accept a signature dialogue every time they send a message to approve the fund being used to pay the very minimal fees. That would just not work if you had a MetaMask pop up every time you wanted to reply to a message or heart something. And so the payer service sits in between the user and the network and can subsidize the costs. The payer service would live in the back end so that it can protect the app's private keys. And you can think of it very similar to a paymaster in the Ethereum universe, where it is making decisions on which messages to subsidize and which messages it might not want to subsidize. And so if you're running an inbox app, you would have a payer service that has a little bit of custom authentication for your app so that you know this is one of my users and not a stranger, and then can maintain a balance in its wallet that gives it enough funds to subsidize the messaging cost per user. Because these messaging costs are fairly low, we hope that you could be pretty permissive with this. We are doing everything in our power to get messaging costs as cheap as possible to make this easy on payers. But ultimately, you still have to decide, do I want to pay for this message or not, even if it's a tiny fraction of a penny? And so we're going to be providing open source repos for the payer service and how you can modify it to meet your needs as an application developer. But this is a thing that doesn't exist in XMTP today, and so I wanted to touch on it here. Now you might be wondering next, okay, what does the payer service do with a message? Where does it go? So if this is a typical message that doesn't need total ordering, it goes to the broadcast network. Broadcast network is explicitly not a blockchain. It is designed for replicating messages without consensus, and that gets one message to every node in the network as quickly as possible. So if I'm talking to one node when I publish a message and you're reading from another node to get your messages, we are minimizing the latency to get the message point to point. And so the broadcast network takes a message in and then sends it to every other node in the network. The reason this can work is because we've explicitly designed the broadcast network to be relatively small, targeting maybe 10 to 20 nodes that are high quality and high performance and located all around the world so they can be close to the end users. Each of these broadcast nodes is then going to sign a message and, importantly, commit to the local ordering. And so while the network doesn't have global ordering guarantees like a blockchain does, it does guarantee the order of the messages that were published to that node. And that can be used to come up with a sensible order inside each client for how you should show messages to the user and which came first. And it should be indistinguishable for a user from total ordering in most cases, because we are going to be routing most writes for a given conversation to one node or another. The node is also responsible for making sure that the payer who signed the message has the appropriate balance to actually pay for the storage of the message. And so each of these broadcast nodes is going to do a check and make sure that you can afford the message you're sending, and then it replicates it out to the rest of the network. This is designed for very low cost storage in the broadcast network. We are able to store messages in a relational database, and we can have nice indexes on it so that it's immediately available to be queried by anyone else as soon as it gets processed, which is very different from blockchain, where you have to wait for some period of time for the network to reach consensus. As soon as you have processed a message in the broadcast network, it is ready to be read by someone else, and that really helps with the speed. Maybe we can hop to the next slide, the Appchain. So this is for the small subset of messages that need total ordering. We do this as an Arbitrum Orbit L3 blockchain that settles onto Base. It has these strong ordering guarantees, and everything that happens on the Appchain related to the XMTP network gets indexed by all the nodes as quickly as they can. This will be higher latency latency the broadcast network, but it should be for pretty rare message types like adding and removing members from a group or initially registering your app on the network. And so in those cases, we think it should be fine to wait hundreds of milliseconds or maybe up to a second in some cases before it's propagated everywhere on the network. These messages on the app chain are paid for just through gas. We don't charge any additional fees beyond the gas required by an Arbitrum Orbit chain. And they spit out events that get indexed by all the nodes. So it's actually very simple smart contracts that are running on the app chain. And we're primarily using the chain just for the ordering guarantees that you get and the censorship resistance you get out of Arbitrum Orbit chain. Even if you don't like our sequencer, you can always use forced inclusion to get your message onto the chain. And so the app chain provides the last line of censorship resistance, where even if every other part of the network doesn't want your message to be shown, you can use forced inclusion on base to get your message displayed. And so that's a really powerful tool that shouldn't be used very often, but allows us to credibly say that this is a truly censorship resistant network, even with really extreme scenarios of all the nodes and our sequencer working to prevent your message coming onto the network. So I think those are the main moving pieces of the app chain. I can talk a little bit about timelines. We're expecting that the new decentralized network is going to launch in H2 2025. And there'll be plenty of advance warning before anyone has to upgrade.